Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And the topic today again comes from one of my subscribers, and the question was they had heard about the marine layer a lot, and what is that and how does that differ from lake effect, which we hear about in the wintertime with snow. And basically one of them is in a very stable environment and one is in a not so stable environment. So try to briefly go over what the major differences are here. So let's get started. And first of all, the marine layer is associated with stable conditions induced by the cooling of air near the surface by a cool ocean, which happens off the west coast all the time. At the same latitude, the water temperatures on the west coast are much, much colder than they are on the east coast, because we have the Gulf Stream transporting warm water northward. They have the California current transporting cold water southward, okay? So if you go to Los Angeles and you think, oh, they're in Southern California, their water should be warm. Doesn't work that way. You really have to head down into Mexico before you get water temperatures that are comparable to what we have along the Carolina coast during the core of the summer months. So anyways, it's induced by the cooling of the air above this cool water. And it can be associated with clouds and fog, but that isn't always the case. It all depends on exactly how moist the environment is, whether or not you get the clouds and the fog associated with that. But there are some times that, if you've ever watched a baseball game out in San Francisco, is that sometimes they'll just be able to watch this wall of clouds and fog move in from the Pacific Ocean. So that can happen. Now, lake effect snows are created in a very unstable environment where very cold air passes over relatively warm lake water. This creates a very steep temperature lapse rate and allows air parcels to become buoyant. In other words, they're warmer than the environment that they're in, and they rise very quickly, accelerate upward very quickly, much like thunderstorms do. And this can result in intense localized bands of heavy snow downwind of the lake. So let's try to look at this graphically here. This is the marine layer, and that's my poor man's excuse for the ocean. And there you have the land. Now, the water is fairly cold, okay, so it cools the air directly above that water. But the overall environment is actually fairly warm. So it's a stable environment where it's cool near the surface, and then it's actually relatively warm as you head higher up into the atmosphere. And so that makes it a stable environment. And so, I moved that little gray area. That was my poor man's representation of the marine layer, and I moved it in order to make another modification, and I forgot to move it back. So it's supposed to be this square or rectangle here is supposed to be down in here, okay? And so if it gets really, really hot inland, and it can in California, like in Death Valley and places like that, that lowers the pressure, and the pressure gradient force, which always blows from high to low pressure, will then move that marine layer inland, okay? So you will see that gray area move to the right. It just was supposed to move to the right down here instead of up here. Sorry about that. All right, so now let's take a look at the lake effect snow situation. So we've got water again and land, but it is very, very cold. The air coming in, like maybe one of the first Arctic outbreaks that occurs during the late fall. I actually went up to Buffalo several years ago when just south of Buffalo, one of the suburbs there got 80 inches, and that was in late November, okay? So this can happen, and it makes sense because the water is still relatively warm from the previous summer, and then you bring really cold Arctic air over top of that, and all of a sudden you got an explosion on your hand. So it's relatively warm right above the lake water, okay, but very, very cold aloft, and so that's an unstable environment where the air parcels are able to accelerate upward very, very quickly, and then you get all of these clouds that form, and you get snow squalls that are downwind of the lake. Now, there are a number of things that can help with upward motion to wring out the snow from those clouds. One of them is speed convergence, where there's less friction over the water than there is over the land. So let's say the water or the wind is blowing at a really good clip here, and then it slows up over the land. So we have a piling up of mass right along the beaches, okay, or just inland, and you have convergence, and of course low-level convergence produces upward motion, and you get clouds and precipitation. Another thing that can happen, and this happens a lot when the wind is blowing like the entire length of Lake Erie or Lake Ontario, is that there's something called frictional convergence, but instead of it being speed convergence, it's directional. And what happens is that over the land there's more friction, and so the wind is actually bent toward the lake, while over the middle of the lake it's blowing pretty much straight, okay, the entire length of the lake. And so you get convergence on the lower side of the lake, if you will, or like in the case of Lake Erie and Lake Ontario, the southeast side of the lake. And so you'll get frictional convergence, and you can get bands of heavy snow that will show up that way as well. So a couple of different ways that you can get convergence in the wind field, which aids in the process of producing these really, really heavy snow squalls, all induced by the fact that you have cold air over top of relatively warm water. So I hope that makes a little bit of sense. Marine layers stable, lake effect snow unstable. That's probably the biggest difference between the two. All right, that's bonus weather video number 1 for this week. Hope you found that interesting. Next one coming up Wednesday, next daily weather update coming up tomorrow. We will see you then. In the meantime, have a wonderful Monday evening. See you later, everybody.